Hello everyone, let us solve the very first question from today's weekly contest, that is longest strictly increasing or strictly decreasing subarray. So in this question we are simply given an array of integers nums and we need to return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. So notice that first of all I need to return the length of the longest subarray, right? And this longest subarray, what should be its property? Its property should be that it should be strictly monotonic, right? It can be increasing or it can be decreasing, doesn't matter, but it should be monotonic. Okay, so what we will do in this question is to solve this question. Let's come to the approach directly because the meaning is quite clear. So first thing is we'll find the length of the longest strictly increasing subarray, and then we will find the length of the longest strictly decreasing subarray, and among them whichever is the longest, right, we will return that. All right, so let us see how to find the length of the longest strictly increasing subarray, right? So let us say I'm given this example, right? So what I can do is I can have two variables. Okay, so one variable let us refer to as length, and it will initially be 1. So obviously an element itself is also a subarray, correct? And it can be the length of the longest strictly increasing or strictly decreasing subarray. For example, if you see this case here, right? So another thing to notice here is strictly increasing means you cannot include equality, right? So here all the elements are equal, so you might say that okay, all of them are strictly increasing or strictly decreasing. No, strictly increasing means there should be no equality involvement, right? So here you can see that this element itself, 3 alone itself, also gives me a subarray, right, which is increasing or decreasing because there's only one element, right? Okay, so that is the reason we are taking length as 1, and we are going to take another variable that's called max length, and it will initially be also 1, right? Now what we'll do is we'll go and iterate inside of nums. So we'll begin our iteration here. So we'll begin our iteration at the 1th index, right? At the 1th index. So we are at the 1th index. Now what we're going to do is, see, for this index we've already included the length and the max length, right? Now we'll check, we'll compare this element with the previous element, right? So if this element is greater than the previous element, then I'll increment my length, right? All right, so now what I'll do, I'll increment my length. So I'll make this as 2. All right, and also I'll increment my max length because length became greater than max length. So max length should be updated to 2. Now I'll go and move my pointer to the next element. So now I'm at 3, right? So now I can see that 3 is not greater than the previous element. That means that obviously this particular subarray, what I'm trying to do is I'm trying to extend the subarray, but this particular subarray is definitely not a strictly increasing subarray. So that means I can skip all the part up to this point, right? Reason being that including this part, right, I will never get a subarray which is a strictly increasing because 3 is breaking that sequence. All right, so I'll say now do what, make your length 1. Now consider all the subarrays starting with 3, right? And for them consider which are the strictly increasing subarray, right? So now you'll go to 3 again. Now there is equality. This element is not greater than the previous element. That means you cannot do anything, right? There is no way that you can include this particular subarray, this part, right? And you can extend and form other subarrays of length greater than 1. So again, update length to 1. Obviously it's 1 only. So then you'll move to this pointer, and here this element again is less than the previous element. That means you cannot form the subarray using this element. So now you can see that the max length is going to be 2, right? So what we are basically doing is we are going to iterate in this array, right? And we are going to start our iteration from the 1 index, and we are going to compare it, each and every element with its previous element, right? So if the current element is greater than the previous element, that means I can increase or I can extend my subarray, right? So I'll increase my length, right? And each time I increase my length, I'll also keep updating my max length. So this way I'll be able to find a strictly increasing subarray. Similarly, if I want to find a strictly decreasing subarray, so everything is going to be the same. This is how you're going to calculate the length, the max length, right? But there what you'll do, you will simply check that if the current element is less than the previous element, right, only then increase length. Otherwise what you have to do, if let's say let's do a dry run for this as well. So length is going to be initiated to 1, max length is going to be again initiated to 1, and now what you're going to find, you're going to again start the iteration here. Now you can see this element is greater than the previous element. That means it is not going to form strictly decreasing sequence, right? So what you'll do, you'll update your length to 1. So it's already 1, doesn't matter. Let us move ahead. So now you'll say that length is 1. That means you'll say this element you are considering as the start point of your subarray. Now, as soon as you come to 3, you'll see, okay, 3 is less than the previous element. That means I can increase my length, right? So I can extend the subarray 4, right? I can extend the subarray 4 with this element. So this is going to give me strictly decreasing order. So I'll increase my length to 2, and also length is greater than max length, so I'll also include or update max length here, right? So now you can see that all right, so now we'll move ahead in our iteration. So we'll come here at 3. So again, equality is there. So as I said, whenever there is equality, we cannot consider that particular sequence is strictly decreasing, right? Equality is not supported, so you'll set the length as 1 again, and then again come to 2. So you can see 2 is less than the previous element, so you can update your length to 2, right? So I hope how we are calculating for strictly increasing, strictly decreasing subarray, that is clear to you. So this is basically what we had to do. So we're going to take 4 variables. So we'll take the length. This length we are referring to as increasing length and decreasing length. So these two variables will take everything initialized to 1, and this max length, I'm just going to write increasing max length, right? It will also be 1, and decreasing max length, and it will also be 1, right? So using these 4 variables, we'll update increasing max length, decreasing max length, and in the end we will simply return the maximum among these, right? So let us look at the code, and then it will be more clear. So see here, first, this is the base case that when there are no elements in your array, definitely the size or the longest sequence is going to be of 0 size only, so return 0. Now declare these 4 variables. So increasing length and increasing max length, this increasing length is going to help you calculate the length of the different subarrays, and you can update the maximum length that you encounter while iterating inside of the increasing max length variable. Now you'll start your iteration. As I said, start your iteration from the 1 index, because 0th index you've already included here only, right? Now you'll start your iteration, compare the current element with the previous element. So for strictly increasing order, if the previous element is less than the current element, then you can increase your subarray length, that is, you can extend your subarray. Otherwise, you have to set the increasing length to 1 and say that whatever the current element is, for the further iteration, I'm going to consider this as the start point of the subarray. Now after that, you can simply keep updating the increasing max length, so that the maximum length encountered while iterating, that is the maximum length or the longest strictly increasing subarray, is included here. Similarly, you have to do it for the decreasing part, and then you can simply return the length, the maximum length among the decreasing max length and increasing max length. So I hope now the question is clear. And here, if we discuss the time and space complexity, then you can already see space, we are using no space, there is no extra space used, only variables. So space is constant, and for time complexity, we are only iterating once here and another time here. So 2 linear iterations, so which basically means our time complexity is linear, big O of n, and space is big O of 1.